The universe beckons. It calls to us from the depths of our very being. We are, after all, children of the stars. Our ancestors looked up at the night sky and dreamed of reaching those distant points of light. Today we stand on the cusp of making those dreams a reality. The quest to explore beyond our solar system, to venture into the vast expanse of interstellar space, is perhaps humanity's greatest challenge. It is a challenge fraught with danger, uncertainty, and unimaginable technical hurdles, but it is a challenge we are destined to embrace. The spirit of exploration is woven into the very fabric of our species. It is what drove us from the trees across the oceans and into the skies, and now it compels us to reach for the stars.
8, 7, 6, 4, 3, 2, 0, and liftoff for the final launch of Endeavour, expanding our knowledge while expanding our lives in space.
Houston, Endeavour, all program.
Roger, roll, Endeavour.
Houston is now controlling.
The Cold War between the United States and the Soviet Union spurred rapid advancements in science and technology, particularly in the field of rocketry. The Soviet Union launched Sputnik, the first artificial satellite, in 1957. This small, beeping sphere marked the beginning of the space age and demonstrated the potential of human ingenuity. The world watched in awe as Sputnik orbited the Earth, a visible symbol of human achievement and a harbinger of the technological race to come. The space race had begun, a fierce competition between the United States and the Soviet Union to achieve superior spaceflight capability. This race was not just about technology, it was a battle for ideological supremacy. Soon, both the United States and the Soviet Union were sending humans into orbit. Yuri Gagarin became the first human to journey into outer space in 1961, a monumental achievement for the Soviet Union. Then in 1969 came the ultimate prize, humans walking on the moon. The Apollo 11 mission, led by NASA, saw Neil Armstrong and Buzz Aldrin take humanity's first steps on another celestial body. Neil Armstrong's words echoed across the globe. One small step for man, one giant leap for mankind. This moment was a unifying event watched by millions around the world. Since then, our exploration of space has continued at an accelerating pace. The 1970s and 1980s saw the development of space stations like Skylab and the launch of the Space Shuttle program, which made space travel more routine. We have sent probes to every planet in our solar system, each mission expanding our understanding of the universe. These robotic explorers have ventured where humans cannot yet go, sending back invaluable data. Robotic explorers have landed on Mars, our neighboring planet. Rovers like Spirit, Opportunity, and Curiosity have traversed the Martian surface, conducting experiments and searching for signs of past life. They have beamed back breathtaking images, revealing the red planet's rugged terrain and providing clues about its history and geology. We have built the International Space Station, a testament to international collaboration. This orbiting laboratory has hosted astronauts from around the world, conducting experiments that benefit life on Earth and pave the way for future space missions. It is a stepping stone to further exploration, serving as a test bed for technologies and systems that will be used in missions to the Moon, Mars, and beyond. But these achievements are just the beginning. The future holds even greater possibilities. From returning humans to the Moon to establishing a permanent presence on Mars, they are the first tentative steps of a species destined to explore the cosmos. As we look to the stars, we are reminded of our boundless curiosity and our relentless drive to push the boundaries of what is possible. The journey has only just begun, and the stars await. The greatest obstacle to interstellar travel is quite simply the unimaginable vastness of space. When we look up at the night sky, the stars seem so close, almost within our reach. Yet the reality is far different. The distances between these celestial bodies are so vast that they stretch the limits of our imagination. The distances are so immense that they are difficult to comprehend. For instance, our Milky Way galaxy alone is about 100,000 light years in diameter. This means that even if we could travel at the speed of light, it would take us 100,000 years to cross from one end to the other. Even light, traveling at the fastest speed possible, takes years to cross the gulf between stars. To put this into perspective, light from the sun takes about 8 minutes to reach Earth. However, light from the nearest star, Proxima Centauri, takes over 4 years to get here. Consider this. The Voyager 1 spacecraft, launched in 1977, is the farthest human-made object from Earth. It has been on an incredible journey, sending back invaluable data about our solar system and beyond. It has been traveling at over 38,000 miles per hour for over 4 decades. Despite this impressive speed, it has only just begun to scratch the surface of interstellar space, yet it is still over 15 billion miles from Earth. This distance, while staggering, is minuscule compared to the distances between stars. It would take tens of thousands of years for Voyager 1 to reach even the nearest star system, Proxima Centauri. This highlights the monumental challenge we face in attempting to travel to other stars. These distances are not merely a technological challenge. They represent a fundamental barrier that we must overcome if we are to become an interstellar species. They are an existential one. The vastness of space forces us to confront our place in the universe and the limits of our current capabilities. They force us to confront the limits of our current understanding of physics and engineering. Our current propulsion technologies are simply not up to the task of interstellar travel.
Interstellar travel is not a question of if, but when, said renowned physicist Michio Kaku. He believes that with advancements in technology and a deeper understanding of the universe, we will one day overcome these challenges. The distances involved are daunting, but not insurmountable. Human ingenuity has always risen to the occasion, and the dream of interstellar travel is no different. We simply need to develop the technology to bridge the gap. This will require breakthroughs in propulsion, energy sources, and perhaps even new physics. The journey to the stars is a long one, but it is a journey worth undertaking. The future of humanity may well depend on it.
To conquer the vast distances of interstellar space, we will need revolutionary propulsion systems. These systems must be capable of overcoming the immense challenges posed by the sheer scale of the universe. Traditional chemical rockets, which have served us well for decades, simply won't cut it for interstellar travel. We need something far more advanced, something that can push the boundaries of our current technological capabilities. Systems that can propel spacecraft to speeds approaching the speed of light. Achieving such speeds would drastically reduce travel time to distant stars, making interstellar exploration a feasible endeavor. Imagine being able to reach the nearest star system, Proxima Centauri, in just a few years instead of millennia. This is the promise of advanced propulsion systems. Several concepts are being explored, each with its own set of challenges and possibilities. From harnessing the power of nuclear reactions to utilizing the mysterious properties of antimatter, scientists and engineers are leaving no stone unturned in their quest to develop the ultimate propulsion system. Each concept brings with it a unique set of technical hurdles, but also the potential for groundbreaking advancements.
Nuclear pulse propulsion, once relegated to the realm of science fiction, is now being seriously considered. This concept, originally proposed in the 1950s, involves using nuclear explosions to propel a spacecraft. The idea is to detonate a series of small nuclear bombs behind the spacecraft, creating powerful shock waves that push it forward. This method involves detonating a series of small nuclear explosions behind a spacecraft. Each explosion generates a massive amount of energy, which is then harnessed to propel the spacecraft forward. The key challenge here is to control the explosions in a way that maximizes thrust while minimizing damage to the spacecraft. The force of the blasts would propel the craft forward at incredible speeds. If successfully implemented, nuclear pulse propulsion could enable spacecraft to reach a significant fraction of the speed of light, opening up new possibilities for interstellar travel.
Antimatter propulsion, while still highly theoretical, holds the potential for even greater speeds. Antimatter is the mirror image of normal matter, and when the two come into contact, they annihilate each other in a burst of pure energy. This energy release is far more efficient than any chemical or nuclear reaction we currently use. Antimatter, when it comes into contact with normal matter, annihilates in a burst of pure energy. This annihilation process releases an enormous amount of energy, which could be harnessed to propel a spacecraft. The challenge lies in producing and storing enough antimatter to make this a viable propulsion method. Harnessing this energy could propel spacecraft to a significant fraction of the speed of light. If we can overcome the technical challenges associated with antimatter production and storage, this propulsion method could revolutionize space travel, making journeys to distant stars a reality.
Another promising avenue is the laser sail. This concept involves using powerful lasers to propel a spacecraft equipped with a large, ultra-thin sail. The idea is to beam intense laser light from Earth or a space-based platform onto the sail, creating a continuous force that pushes the spacecraft forward. This concept involves propelling a large, ultra-thin sail using powerful lasers beamed from Earth. The sail, made of lightweight and highly reflective material, would capture the laser light and convert it into thrust. This method has the advantage of not requiring any onboard fuel, making it a highly efficient propulsion system. The constant pressure from the laser light would gradually accelerate the sail to incredible speeds. Over time, the spacecraft could reach velocities that are a significant fraction of the speed of light, enabling rapid travel across interstellar distances.
These are just a few of the ideas being explored. The quest for a viable interstellar propulsion system is a monumental challenge, but it is one that humanity is determined to overcome. The development of such a system will require unprecedented levels of innovation, collaboration, and perseverance. The development of a viable interstellar propulsion system will be one of the greatest technological achievements in human history. It will open up new frontiers for exploration, expand our understanding of the universe, and potentially pave the way for humanity to become an interstellar species. The journey to the stars is just beginning, and the possibilities are truly limitless.